God bless you and welcome to lesson 3. Lesson 3. We want to consider the repetition, right? Repetition construct. Okay, consider the repetition construct to determine the um the let's say average of the first 1000 number. Right, how do we go about that? So first 1000 numbers, so uh, um, let's consider this. So of course, if we check sequence of numbers, you see that a number begins from 1, 2, 3, 4, 5 down to the last is going to be 1000, right? Now before we proceed to this, we will need to our number. Okay, our number is going to begin to count from 1. Okay, right. Okay, so and to stop 1000. Okay, then we need some. We'll start from 0. Okay, and of course our average our average uh, our average will be I want to see average. Okay, all right, for us to write, so this is the completed variables we need. Of course, we know our n is going to start from 1 and must not exceed 1000. Then our cumulative sum, okay, cumulative sum will be 0. Okay, then of course our counter will also begin from 0, right? So this counter is to begin to count from 1. Okay, begin to count from 1 to 1000, right? Okay, now so once we begin, but let's consider our expression, our update for these two. Let's see how we need to update let's see values and update. How do we need to update, or how do we need to increment? It's very important to know how they will increment. So for n equals to 1, okay, it's going to be n equals n plus 1. Then from sum equals to 0, it will be sum equals sum plus n. Then for counter, starting from 0, it will be counter. Okay, counter will be updated by 1. Okay, right. Then of course our average will be computed for us as average will be summed divided by the counter. So okay, So this is what we need to compute this, right? Okay, now as usual we will start. Okay, we'll start. Sorry, it's just kind of so we start. Okay, so start. um of course we have to define our values for both and sum and counter. Okay, so we are going to, yeah, it's going to be a process. So let n start from 1, let sum, then let counter be 0. Okay, then of course let's not forget we must always start. Okay, the next thing is we'll proceed. Now what? We want to check uh, okay, so is all right. So is n, okay, is n less than equal to 1000. Okay, so if it is a yes, the yes, we'll proceed this way. We have a expression and this is yes, will be updated by 1, sum be updated by n. Okay, then of course our counter will be updated by the value of 1. Okay, so now we have this. Okay, so otherwise is the process. Okay, the process uh, so we have this. Then of course at this point it will keep looping. There's going to be a loop here. This will be better seen in our in our in the program. Okay, so um we'll finally display this point. We display. Okay, our average will be sum, right, um, divided by counter, sorry, it's going to be let's put it this way, sum average sum by counter, right? So so want to see how we can best go about, right, right, and right. Okay, then at this point we would have to uh, um, this place, it's computing, sorry, so this is a process. Okay, then of course uh, it will let's display average, right? Display average, then before the loop terminates. Okay, because at this point the loop will have to stop. Okay, so it's going to be a stoppage here, right? So basically this is the algorithm. We have the starting point. Okay, start from here, then of course let n be 1, let sum be 0, let counter be 0. Okay, then of course we will check if the value of n is less than or equal to 1000. Okay, and if it is, it will update the value of n to 2, and of course to add um, oh sorry, let's hold on for a minute. Can this be before we update um, n, because if sum is 0 and it's update n, n is 1. Okay, we are saying let n be 1. Okay, if it should add 1, it becomes 2. So this point we may not get the accurate it will be 2 at this point, right? Let's see, I was hoping if this could be to just be I was hoping if we could have this like this, if we could have these like this. Let's get the sum first because 1 is coming in, then before we can now update the value of n. I think it's safer to have it this way, right? Okay, so it's safer to have it this way. Okay, then of course n will be updated. Okay, then of course our counter is updated. Then of course when the loop will break out, the moment it is 1001, it will break out of this point. But just know that this counter must have counted up to 1000. Okay, and that's why we were not using n, because n, or if we have to use n, I don't want to make it complicated. Okay, we would have come here and say n minus 1, but to save us of the explanation, okay, we just will stick to our counter updating too, right? So if you do not want to make use of counter, just know that by the time this loop breaks out, it's going to be 1001. Okay, so for you to get 1,000, you just simply come here and say n in bracket n minus 1. It will also give you 1,000. Okay, but let us use it this way. Okay, right. So this is the start, and of course this brings us to the end of the algorithm, which showed, more importantly, it had to do with what? Repetition. Okay, had to do with repetition. That's the most important thing here. Has to do with repetition, right? So God bless you. Have a wonderful day.